Hey guys, what's going on? Let's go ahead and get right into it, guys. So I'm going to show you guys how to find the AP Calculus free response questions. You can see my history there of what I've been looking. So here it is, Shady Rays. In case you're wondering, those are like sunglasses, and they're actually pretty cool sunglasses. Anyways, I'm not sponsored by them or anything, and yeah, no, I googled how many liters are in a gallon earlier today, and how many I should drink, and all that good stuff. I'll probably delete this from the video, or who knows, maybe I'll add it for character. You know what I mean? Like it adds to the video, like, oh, look how cool. I don't know. Give it a thumbs up, guys. Anyways, here we go. Google College Board free response questions AP Calculus, and you can see here I clicked on AP Calculus AP exams. This is the one, but I'm going to click on the very first link. I see AP Central past questions, and here they are. Awesome. And then notice there's the free response questions are right here. The scoring guidelines are here. And then the chief reader report tells you information. Actually tells you very good information. It tells you, how many, the score distributions for how many fives, how many fours, how many threes. You can see that the average was 2.94 and all that good stuff. But anyways, that's not what I wanted to show you. What I really wanted to show you is the scoring statistics. So here, this tells you how many points each question got, guys. So question 1, on average, it was 2.82, 4.21, 3.36, 2.77, 2.59, 3.65. So over the last 5 years, in 2019, there was a question that got 1.81 points. We will talk about that one later. There's actually one that got lower than that, and that we've already spoken about, actually. So I'm going to include that video in a little bit. But in 2017, excuse me, in 2017, question 4 only averaged 1.54 points, guys. Now that's pretty, I'm not going to say that's rare, but that's pretty low. So that means a lot of students thought that question was hard. Like I said, in 2019, there was one that was 1.81. I'll do a video on that question later. So why am I doing a video on this one in particular? Because I actually went over this question during spring break. Let's see, the exact day that I did this question was, I don't have it. I think it was March 11th. So I went over that question March 11th. The spring break, it was, I can't remember what was March 11th anymore. I guess I can look at my calendar here. Was it a Tuesday or something? April, May, the other way. March 11th. It was a Thursday. So if you go back and you look on my YouTube channel for Thursdays, you'll find it. But don't worry, relax. I'm going to go ahead and include it in this video. And let's see what made this question so tough, guys. All right, so hopefully check out the video, guys. Hook it up with a thumbs up if you feel like it's entertaining. And yeah, let's see what made this question so hard, guys. All right, later. Hey guys, what's going on? What a day today has been. It's just been jam-packed, and it just keeps getting better. So all right, let's go right into it. I hope you are in good spirits. I hope you're doing well. And wherever you're at, guys, try to make it a good day. And yeah, let's get right into it. So this one is a differential equation problem from the 2017 exam. And let's see what we got. At time t equals 0, a boiled potato, oh, that's cool, we're talking about potatoes, is taken from a pot on a stove and left to cool in the kitchen. Okay, cool. The internal temperature of the potato is 91 degrees Celsius at time t equals 0. And the internal temperature of the potato is greater than 27 degrees for all times t is greater than or equal to 0. Okay, so it's always larger than that. The internal temperature of the potato at time t minutes can be modeled by the function h that satisfies the differential equation, blah, where h of t is measured in degrees Celsius and h of 0 equals 91. And they gave us that. They gave us that right here. The internal temperature of the potato is 91 degrees Celsius at time t equals 0. Okay, letter A. Write an equation for the line tangent to the graph of h at t equals 0. Use this equation to approximate the internal temperature of the potato at time t equals 3. All right, so we want a tangent line. So we need two things. We need a point and a slope. We got a point. The point is 0, 91. So now I need a slope. How do I get my slope? Well, we got dH/dt here, and that's going to give me my slope. Or that's going to give you your h slope, right? So I'm going to plug in my temperature, because that's what it says. I have an h here, it doesn't have a t. So most of the time you plug in a t, but this time you're going to plug in an h, right? So we're going to plug in that h, and we're going to see what we get for our slope. So I'm going to write dh dt. And when t is 0, if you want to write a little line there where t is 0, no big deal, is equal to negative 1/4, parenthesis, 91 minus 27. And this is a no calculator question, guys. Let's see what this is. Negative 1/4. If you don't feel comfortable, you can actually leave it like that. But I think we can do it. Let's see. 91, 81, 71, 61, 62, 63, 64. 64. Ooh, I want to say 4 goes into 64. Let's see. 4 times 15, 15, 30, 60. 4. Oh, okay, perfect. So I know that 4 times 15 is 60. So then that means 4 times 16 must be 64. So negative 16. Because that's like 64 divided by 4. So I got it, guys. So I need point and a slope. So here we go. Y minus 91 equals negative 16. And I guess technically it's t, right? But I'm going to write x. X minus 0. So here's what I'm going to use to approximate h of 3. So I'm going to move that 91 to the right-hand side. And I'm going to say this. H of 3 is approximately... I don't know what's going on, guys. What's going on with my pen here? Is approximately negative 16 parenthesis times 3 plus 91. And I think we can do that. Let's see. 15, 30, 45, 46%, 48. So negative 48 plus 91. And then 48, 58, 68, 78, 88, 88, 88, 89, 90, 81. I want to say it's 40, negative 43. And I think that's correct. No, positive. 91 is bigger than 48. Yeah, I think we're good, guys. 48, 58, 68, 78, 88, 88, 89, 90, 91. Yeah, we're correct, guys. Use this way to... Okay, so there it is. The approximate temperature. And maybe you want to write a sentence. I'm going to leave it right there. H of 3 is approximately 43 degrees Celsius. All right. That was fun. Use the second derivative to determine whether your answer in part A is an underestimate or an overestimate of the internal temperature of the potato. Oh, okay. So here's the logic behind it, guys. You have a curve. If the curve is concave down and you have a tangent line, your tangent line lies above the curve, so it's an over approximate. If you have a curve and it's concave up and you have a tangent line, your approximate is an under approximate because you use the tangent line and the curve is above the tangent line. So hopefully that logic made sense. So think about it. Concave down, tangent line used to approximate, it's going to be over. Concave up, tangent line used to approximate, it's going to be an under approximate. So that's the logic behind it, guys. So let's go ahead and take the second derivative. So first I'm going to write my first derivative here. Or you know what, I can just zoom out. So here we go. Second derivative, and I'm sorry that it's writing funky here. And I see just a linear expression here, and it looks like it's just going to be, well, okay. Sorry guys, I'm getting text messages here. If you were to distribute that, which you don't have to, by the way, it would have been negative 1/4 h minus or plus 27 over 4. That 27 over 4 is a constant. I wouldn't worry about it. The derivative of negative 1/4 h is just going to be negative 1/4 dh dt. And I can bring that back in, negative 1/4 parenthesis, and then you put back what dh dt is again. dh dt was a negative 1/4 h minus 27, close. Negative times a negative is a positive. So let's see, second derivative is equal to a positive 1/16 h minus 27. Now they did give us some message. The internal temperature of the potato is greater than 27 degrees. So h is going to be larger than 27 all the time. H is always larger than 27. So because of that, the second derivative will always be positive. So I'm going to make a statement. So remember what this means. This means that h is concave up. If you're concave up and you use a tangent line, your approximate, if you use a tangent line to approximate, the tangent line is going to be a lower y value than where you're really at. See? You're really up here, that y value, whatever that y value is, and you're down here. So, here we go. Since the second derivative is positive, comma, our tangent line approximation at t equals 3 will be an underestimate. There it is. Since the second derivative is positive, our tangent line approximation at t equals 3 will be an underestimate. I think that's full credit. We'll find out in a little bit when we look at the rubric. This is just the same story again, guys, because I took up another page. And it says, for t less than 10, an alternate model for the internal temperature of the potato at time t minutes is a function g that satisfies the differential equation. So they give me this differential equation, where g of t is measured in degrees Celsius. And again, they give me my initial temperature. Find an expression for g of t based on this model. What is the internal temperature of the potato at t equals 3? Is that the last question? That is. Okay. So we're going to separate our variables here, guys. I'm going to leave the negative there with this, but I'm going to move the g minus 27 and the 2/3 to the other side. So here we go. dg over g minus 27 to the 2/3 equals a negative dt. So all I did was separate the variables. I multiplied by dt and moved it to the right. I'm going to go ahead and move this up here. So g, that's a g, not a 6. G minus 27 to the negative 2/3 dg equals negative dt. And now I'm going to integrate. Integrate. So let's see what we get here. Plus 1 divided by that. So negative 2/3 plus 1, that's going to be 1/3. So g minus 27 to the 1/3. Let's see, divided by 1/3. So I'm going to have a 3 up here. Yeah, it looks correct to me. Let me just make sure. Yeah, I think we're good, guys. We have a linear term on the inside. That's perfect. So I think we're good. Equals, let's see, what is it going to equal? Negative t plus c. I'm going to use, I think there's a good location to plug in 0 and 91, see what I get. So 3 times 0 minus 27 to the 1/3 equals 0 plus c. So let's see, 3 times, okay, hold on, g. Oops, that's a mistake. That's a mistake. That's a big one, too. How come you guys didn't tell me? I'm kidding, guys. I guess I didn't have to I didn't have to erase everything. When t is 0, the g is 91. 91 minus 27 to the 1/3 equals 0 plus c. So 3 times, let's see, 91, 81, 71, 61, 64. Oh, okay. It's the same thing. Silly me. Equals c. The cube root of 64. I want to say that's 4. Let's see. 4 times 4 is 16. And then 16 times 4, yeah, that's 64. So 3 times 4 equals 12. So there's my c value. So I'm going to write 3. I'm going to continue it right there from that guy. G minus 27 to the 1/3 equals negative t plus 12. I'm going to divide by 3 because we're trying to solve for g of t, see? So I'm going to divide by 3. And I'm not going to bother to reduce that. You could say negative 1/3 t plus 4, but I'm going to leave it. G minus 27 to the 1/3 equals negative t plus 12 over 3. And now I'm going to raise it to the 3rd power, and I'm going to raise this to the 3rd power. So g minus 27 equals this guy to the 3rd power. And I guess, well, I already started writing it, so too bad. Negative t plus 12 over 3. Of course, you can rewrite this as a single term, negative 1/3 t plus 4 to the 3rd power. Just move the 27 over. So g of t is equal to negative t plus 12 over 3 to the third power plus 27. All right, there it is. And based on this model, what is the internal temperature of the potato? T equals 3. Okay, let's see. G of 3 is equal to negative 3 plus 12. That's going to be 9. 9 divided by 3 is going to be 3. So 3 cubed is 27. And 27 plus 27, 25, 25, 50, 54? 54 degrees Celsius. All right, and then I would write a statement, very quick one. I would say the temperature at T equals 3 is 54 degrees Celsius. Why am I not writing a statement? Well, okay, I'll write it, guys. Let me see, how am I going to write it? The internal temperature at T equals 3, is it minutes? Yeah. T equals 3 minutes is 54 degrees Celsius. All right, there it is. Let's take a look at the rubric and see if we got everything, guys. That was kind of fun, actually. So, which one is from what year? 2007. So, 2007. College Board. Response. 2017. Sorry, guys. Let's go. 2017. And it was question 4. All right. Yeah, we got it. Y equals 91 minus 16t. I think we got it. We wrote negative 16t plus 91. Surprised that they wrote it that way. Where'd it go? There it is right here. Y minus 91 equals negative 16. X minus 0. No big deal. That X looks like a T to me if I move my head a little bit. You'll be fine, guys. You'll be fine with this statement right here. So you're good there. And then H of 3 is 43 degrees. And I think we got that. Yep, 43 degrees. And then our tangent line approximation was an underestimate. So let's see here. Second derivative was that. Boom. H is greater than 27 for T greater than 0. I didn't put this statement here, but I did write H is greater than 27. So I think we're good. Therefore, the graph H is concave up for T greater than 0. Thus, the answer in part A is an underestimate. I think we got it, guys. If we would be a little more specific, I think that would be great. So my apologies if I didn't write super specifics there. Then letter C, I think we did it the exact same way they did it. I don't see any mistakes yet. I hope I don't have any mistakes. Yeah, no, they have the same equation we got. They put they put 12 minus t in the back, so we wouldn't confuse that negative as the whole expression to be negative. They went ahead and put this specific detail here. Oh man, what the heck was that? This is a secure document. Editing is not permitted. Okay. It's not a secure document because you can get it online, but that's fine. Well, I guess it says secured there. So, but anyways, you don't have to be that specific, guys. Maybe I should have, but you don't have to. I think you're still good. I think in the future they want us to be that specific. And there it is. And notice over here that you only got 2 out of the 5 if you didn't put a plus C. So if you didn't put a plus C right there, they'll give you a point just to separate the variables. So just to do that right there, they'll give you a point. So yeah, guys. So let me know how you guys did. I think we got them all. Pretty happy with it. It was a nice little question. I enjoyed it. So hopefully that you guys enjoyed it too. All right. See you guys later. Have a good day, guys. All right. Bye-bye.